Dear students, welcome to my channel Do Maths Perfect. In sound chapter, we are doing second episode Characteristics 2 Sound wave in graph form. This graph indicates less amplitude. This is less amplitude, so less frequency also. In 1 second, less number of frequencies, that means compressions, so less pitch. Here observe, compared to these two, frequencies are more frequencies. So more frequency means high pitch. So in this way we can understand the pitch. Now come to this one, PB, QD, RF, SH. It is the amplitude. As the amplitude increases, loudness also increases. Now, let us learn wavelength. The distance between the points B to F is wavelength. Similarly, D to H is wavelength, or Q to S is also wavelength. That means a distance between any two crests. These two positions are called as crests. Similarly, this J also crest. This D, H, etc. These are trough. So the molecules of the vibrating substance, if they are in a higher position, they are called as crests. If they are in lower level, they are trough. For example, in water, we can create waves. We can see the molecules in upper level and lower level also. Now, PB, this PB, QD, this QD, high amplitude. Compared to these two, amplitude is more. So, louder the sound. A loudness increases as the amplitude increases. As the frequency increases, pitch increases. So now BFJ, observe this, BFJ, they represents compressions and crests. They represents compressions as well as in crests. Similarly, the lower levels D, H, etc. represents rarefactions, and they are the points on trough. Now observe this, A, B, C, D, E. This completes A, B, C, D, E represents one complete sound wave. Similarly, we can say like this also, C, D, E, F, G, one complete sound wave. Or we can say like this also, E, F, G, H, I. That's also complete sound wave. Wavelength. The symbol is lambda. It is like an inverted Y. Definition is the distance between two consecutive compressions or the distance between two rarefactions is called wavelength. Distance between two compressions or rarefaction is wavelength. Frequency, that is F. Number of oscillations per second is called frequency. Number of oscillations in 1 second is called as frequency. Period, that is represented by T. The time taken by the wave to complete one oscillation is called period, time period. Wave velocity V, frequency of wave is F, and its wavelength lambda are related by the formula relation between V, F and lambda, that is V equal to velocity or speed equal to distance divided by time. We know that in science. This distance is nothing but the distance between two compressions or rarefactions, that means wavelength, that is the distance, and divided by time. Now, wavelength is represented by lambda and 1 by time, that is f. Here f equal to 1 by t, that is f. So v equal to f lambda. You should remember this formula for solving problems. So speed or velocity of wave, this v equal to f, that is frequency, into lambda, that is wavelength. Let us do one problem. 20 waves pass through a point in 2 seconds. If the distance between one crest and the adjacent trough length is 1.5 meters, calculate frequency and wavelength. Here, the given points, let us read once again, 20 waves. That means number of waves equal to 20. Number of oscillations, that is 20. In how many seconds? It is given in 2 seconds. Time period is 2 seconds. So frequency means number of waves divided by time taken, that is 20 divided by 2 equal to 10. This indicates that in 1 second the oscillations are 10 oscillations. Therefore, this 10 is represented by the symbol Hz, that is Hertz, frequency f equal to 10 Hertz. And wavelength is not given directly. The given point is distance between crest and trough is given. Distance between crest and trough is half of the wavelength. Therefore, wavelength equal to 1.5 meters plus 1.5 meters, that is equal to 3 meters. Wavelength, that is lambda, equal to 3 meters.